How do parabolas describe projectile motion in physics? Imagine throwing a ball into the air and watching it follow a graceful, curved path before landing back on the ground. That smooth, arching shape is actually a parabola, and it tells us a lot about how objects move through the air. When an object is launched into the air, it moves in a way that combines two types of motion. First, it moves forward at a steady speed because there is no horizontal for slowing it down. This is called horizontal motion, and it stays constant throughout the flight. Second, it accelerates downward because of gravity, which pulls it toward the ground. This vertical motion speeds up as the object falls, and it is affected by gravity's constant pull. When you put these two motions together, the overall path the object takes forms a parabola. This is because the horizontal part moves in a straight line, while the vertical part changes in a way that follows a quadratic pattern. In math terms, the vertical position of the projectile at any point can be described by a quadratic equation, which looks like this: y equals a times x squared plus b times x plus c. Here, y is the height, x is the horizontal distance, and a, b, and c are constants that depend on how fast and at what angle the object was launched. The reason the path is a parabola is because the vertical position changes with the square of the horizontal position, making it a quadratic relationship. The horizontal position changes linearly with time because the horizontal velocity stays the same, but the vertical position changes quadratically because of gravity's constant acceleration downward. When you combine these two motions, the shape that emerges is a parabola, which is symmetrical and U-shaped. This explains why objects like thrown balls, arrows shot from a bow, or cannonballs follow a curved, parabolic path rather than a straight line. From a math perspective, understanding how quadratic equations describe this motion helps us see how algebra connects to real-world physics. It shows that the shape of the path an object takes in the air is not just a coincidence but is directly related to the quadratic functions studied in algebra. So, in simple terms, parabolas describe projectile motion because the path results from a steady horizontal movement combined with a vertical movement that speeds up due to gravity. This combination creates a quadratic relationship between the height and the horizontal distance, which forms the classic parabola shape we see in many moving objects.